Real-time statistics give us immediate insights into what's happening right now across our systems and users. Unlike traditional analytics that processes data in batches, real-time statistics involve tracking and computing metrics as events happen. This immediate processing lets you see what's happening across your systems right now, making it possible to respond to changes instantly rather than hours or days later. Dragonfly is a modern high-performance in-memory data store that serves as a drop-in Redis alternative, but with a key difference. It's built with a multi-threaded architecture from the ground up. This makes it particularly powerful for use cases like real-time statistics, where performance at scale is crucial. Now, what makes Dragonfly particularly effective for real-time statistics is its ability to handle millions of operations per second with sub-millisecond latency. This means your application can track user activities, update leaderboards, or monitor system metrics without creating bottlenecks, even as you scale to millions of users and beyond. In this video, we're going to explore two practical use cases that highlight Dragonfly's capabilities for real-time statistics. First, we'll build a system for monitoring active users across your application. This solution will enable you to effortlessly track weekly, monthly, or yearly active users, even at scales reaching millions or billions of users. Second, we'll implement a real-time leaderboard system that can handle millions of score updates while providing instant ranking information. This is perfect for gaming applications, fitness challenges, or any scenario where competition drives engagement. Now, let's dive into that first project, the active user tracking system, and see how this works in practice. If you want to see the finished project, we'll link the GitHub repo with this video. First, we'll initialize a Redis client for connecting to Dragonfly. As Dragonfly is fully compatible with Redis, we can use existing Redis clients. Then we initialize the client, pointing to our Dragonfly instance running locally at port 6379. It's convention in both Redis and Dragonfly to name keys with colon-separated parts. To help with this, here are a couple of utility functions that will generate keys with a provided prefix, and then the year, and then the month, colon-separated. One will generate a key for the month of the provided date, and the other is shorthand for running the key generator for the current month. For this first example, we're going to be considering an active user, one who has made a request this month. This will be implemented as a middleware in our Express application called Track Monthly Active Users. Now, assuming the user ID is passed in the request body, we use the pf_add command to add the element to a HyperLogLog data structure. If you don't know what HyperLogLog is, it's basically an incredibly memory efficient data structure that can count, or rather estimate, a huge number of unique elements in a large dataset with an acceptably small error rate. Now remember, the structure of this key is monthly active users, the current year, the current date. And we're going to add the current user ID to it. That means that this value in this HyperLogLog data structure will have lots of user IDs in it, which will later return the count. Now it's time to actually add the middleware to requests. This post-user action endpoint is a dummy to simulate user actions, but you would also add any real logic in the route handler function. As you'd probably expect, the same way there is a command to add an element to a HyperLogLog data structure, there is also a command to count the values, pf_count. Now, to use the proper terminology for a moment, we're retrieving the cardinality value from a HyperLogLog. This endpoint will return all unique values, or user IDs, in the monthly active users key for the current month. Now let's say, for example, that we want to combine all values from multiple HyperLogLog structures. Now, to be clear, this isn't the same as using pf count on multiple structures and then adding them. Instead, if a user ID exists in multiple structures, they are counted only once. We start a pipeline operation using Dragonfly, which allows us to issue multiple commands to reduce network round trips. We use the pf merge command to merge the cardinalities of multiple HyperLogLog keys into a new key, which we've created in a variable called merge key. Then, like before, we use the pf count on the merge key. Now we want the merge key to be treated as temporary instead of being there forever, and we only want it to exist for the current and last months. So we're going to expire it at the end of the current month. Now on to project 2. To manage a leaderboard, we're going to create a second piece of middleware. The zincreby command is used to increment a member's value in a stored set. A set, remember, means that a member can only exist once. Being sorted is self-explanatory, although it will be sorted by the value, known as the score, for free. And what's nice about this command is that if the member does not already exist, it will be created with the initial score. So this line will create a member with a score of 10, or increment it if it already exists. And of course, you can define different score increments for different actions. Like our track monthly users middleware, we are going to import and inject add leaderboard points in our user action endpoint. In reality, you may want this to be injected in more than one handler, with different scores being added for a user. Now, to get the top 10 users for the current month's leaderboard, we use the zrevrange command for the current month's key. This command will return members from the highest to the lowest score from index 0 to 9, so the first 10 elements. With scores means that we will include the score value in the return data instead of just the user ID. Then we massage the data and convert the flat array with values alternating between user ID and the score to an object with a user ID and a score property, and then return that to the client. For simplicity, we're only returning the top 10 users. However, you can leverage additional commands like zrank to determine the rank of a specific user. Similarly, other commands in the zrange family can be used to implement features like leaderboard pagination. As we've seen in our real-time statistics examples, Dragonfly brings a lot to the table for developers looking to build high-performance applications. Let's quickly touch on a few key points about Dragonfly that make it especially powerful for these use cases. Firstly, compatibility. Dragonfly ensures Redis compatibility as much as possible, which means your existing Redis knowledge and code can transfer seamlessly. Currently, Dragonfly implements over 250 of the most commonly used Redis commands, making the transition straightforward for most applications. You might have noticed that we use HyperLogLog in our active users tracking example. It's not necessarily a data structure every developer is familiar with, but Dragonfly supports it because our community has shown demand for it. Let's also talk about performance and memory efficiency beyond just the architecture benefits. In our leaderboard example, we used a sorted set. What you might not know though, is that Dragonfly's sorted set is a brand new implementation using a B+ tree underneath, rather than the skip list approach that Redis uses. Our implementation delivers about 4 times the throughput when running with 8 threads, while using about 40% less memory for the same data, which is pretty cool. These performance and memory advantages become increasingly significant as your real-time statistics workloads grow. So whether you're tracking millions or even billions of active users, or maintaining complex leaderboards with frequent updates, Dragonfly's architecture is designed to handle these challenges efficiently. Thank you so much for joining me and watching this exploration of real-time statistics with Dragonfly. If you're building applications that need to process user events and produce statistical insights in real time, I encourage you to give Dragonfly a try. The GitHub repo for today's examples is linked with this video, and we'd love to hear more about what you build with it. Thank you once again, and I'll see you next time. Bye for now.